everyone, welcome to another project from 3D Redbox channel. My name is Mehdi and today I'm gonna break down the texturing phase of this project and we are going to talk about why this strange plane is here and what is the reason behind that. And after that, we are going to transfer this model with the textures to Unreal Engine. And as you can see, we have this model inside Unreal and the material of the leaves and the flowers has translucency and we can control it. And we have other options too in the shader. One of those interesting options here is random color for the flowers, which is based on the object position. And after learning this technique, you can use this random color mode on your object to bring variation, and you can create a custom color input for your leaves to bring customization power into your workflow. Okay, so let's go and start the video. And before jumping to the video itself, let me introduce you the course that we create for Substance Painter for all levels to bring your skills from zero to hero. Learning Substance Painter is easier than ever. Hey all Substance lovers, texture seekers, and awesome future artists. Welcome to Ultimate Course for Learning Substance Painter from zero to hero. Ready to learn how to texture with different projects? Substance Master released a brand new course for those who want to learn to texture with Substance Painter. In this course, we cover from preparing the model to rendering different projects, different challenges. If you want to level up your skill in texturing, come and check the Substance Master Ultimate course for learning Substance Painter. Welcome back to the video and let's start break down the texturing process. For the first step, we need to define the logic behind this plane. So this plane is a placeholder inside the UV island that we can place our texture inside Substance Painter. And as you can see, for each part of the model, we have a representative UV island inside the main UV sheet. This is for the vase, this is for the soil or dirt, and this is for the flower, and this is for the leaves. And as you can see, for the flower and the leaves, we use overlap technique. It means we have so many UV islands in the same shape. We stack them on top of each other and just place one of them inside the main UV sheet, and we paint the information on that UV. And after that, all the others outside the main UV sheet, they are going to read the information from the inside. But what about the trunks and the branches? For this part, because they are in different shapes, a different scale, we couldn't use one of them as a main representative inside the main UV island. So we just move all the UV island related to the trunks and the branches outside the main UV island and place a plane and feed the UV of that into our UV layout as a placeholder. So on this placeholder, we just put the information for the branches. And after that, all the branches outside the main UV island, they are going to read the information from this placeholder. So this is the logic behind this plane. For the next step, you need to tweak some setting inside the texture set and the shader one. In the shader setting, you need to enable double-sided, and for the opacity, you need to enable alpha blending. For the texture set setting, you need to add 3 different channels. First, opacity for defining opacity on the textures, and the second one is user 0, which we are going to use for the translucency mask, and the output type should be on L8, which means it's a black and white output. And for the user 1, which is a color ID for customization system inside Unreal, you need to define it as a sRGB 8, and we are going to use these two in the layer stack. Okay, so let's have a quick breakdown on the layers. For the first layer, I just used a fill layer for the main structure, and as you can see, all the channels are turned on here. And for the opacity, I choose 0 because I don't want to have any kind of opacity on the texture, and I want to define the opacity of each part separately. Okay, so let's go for the vase, and as you can see, we have a fill layer with solid color and the opacity as 1. The second layer is the pattern layer. So for the pattern layer, because we have a round shape, I just use a different type of projection, cylindrical projection. And as you can see, I can control that on the scale and the position. So in this way, we don't have any kind of seam on the texture. But if you go to the UV projection you have the seam here, and it's not related to the texture. The texture is seamless. The problem here is this space on the UV, which created for the padding and the margin in the UV packing process. So for avoiding this kind of issue, we just change the projection to cylindrical projection, okay? So I just want to define some white area on the pattern and just add another layer of the pattern. So here in this layer, we just have solid color, roughness information, and a little negative height. But as you can see, we have this seam, so we need to go to the mask, go to the trim, and just change the projection to cylindrical. And that's it. So I just need to place it on the right place, and we don't have any kind of seam or extra errors, okay? So let's go for the next one. The next one is a roughness information, which is extra information layer for the roughness. And at the end, I just add effect of the sterilization to have this result at the end. So that's it for the vase, and let's go for the soil, which is just pretty simple. I just load a soil texture here and create an anchor point and bring the anchor point to the height to add some extra information on the normal channel here. So as you can see, this is the result that we have without this layer, and after that we have some information regarding to the soil on the normal channel. Okay, perfect. Let's go to the next layer. Layer is for the leaves. So if I go here into the mask, as you can see, we have a black and white mask based on the UV. And for the texture part, the information inside the layer, I just grab a picture of the leaf and create this information from that. So I put all the information and resources that you need into the project file section that you can download from the link in the description. So this is the result, but the opacity is not super accurate. So I just add a bevel filter on the layer, just only apply on the opacity, create a level to affect on the opacity and control the opacity amount, okay? And add warp to have some organic shape on the edges. And just for control on the roughness, I add a fill layer with just only roughness channel to override on the information that I have on the roughness input. So that's it for the leaf. So let's go for the flower. So as you can see, again, we have a mask based on the UV. And for the information, I have a layer with the opacity on 1, and the base color is a texture that I create based on the real photo. Okay, now let's talk about the next layer, which is for the branches. And as you can see, I just placed the texture that I had for the trunk on the placeholder here. And if we go there and look at the trunks here, all the UV of these branches and trunks and objects here just receive the information from this placeholder. So at the end, the texture would be like this for the vase, for the soil, for the flower, for the leaves, and here for the roots, trunks, and branches. That's it. So at the end, I just add a sharpen filter on the base color. And now it's time to create mask for customization system inside the Unreal. First of all, I just put a fill layer which users 0 and 1 are enabled, and the information of both of them are black. So 0 for the user 0 and black for user 1, which is a color output. So the next layer is just for translucency. And as you can see, the user 0 is 1. So if I go to the user 0 preview, it means on the white area we are going to have translucency. And on the black area, we don't receive any kind of translucency. And let's go for the RGB mask inside the user 1. So for the flower mask, I just put red on the user 1. For the leaf mask, I just put green for the leaves. And for the vase, as you can see, I create a blue mask. And because on the vase we have a pattern on white background, it means if I want to change any color here, I just go and target the blue area, not the white one. So I can customize the color inside the engine with this mask. Very easy. And for example, if we want to change the hue saturation in the vase mask, we can just put the vase completely because hue saturation change doesn't affect on the black or white areas. Okay, so we just create all the information that we need for the Unreal Engine, and it's time to export our textures. But because we have a custom solution for the mask, we need to modify the template a little bit. So let's go to the file, export, into our template here, and I just want to create a new channel. So let's copy the name from this place to here, and call it MA as a mask. So the user 0 should go to the opacity because it's black and white, and the user 1, because it's RGB, it should go here as a RGB channels. And that's it. So if I export under UE5 template, it's going to export diffuse or base color and opacity in the alpha channel, normal as a complete texture, ORM as a channeled packed mask with AO, roughness and metallic, and emissive in the alpha channel. And because we don't have any kind of emissive here, it's going to be black. And for the mask, we just export user 1 as a main RGB channel and user 0 as a alpha channel. And it should be better on Targa format. Let's go to the setting, choose UE5 template and export with a 2K size. Okay, now we are in Unreal Engine and I want to import all the assets that we create from model and the textures into Unreal Engine from import section. So let's select all the textures. And remember, for mask, we need to open the texture and just turn off the sRGB option here and hit the save. Let's do the same for the mask and ORM. Perfect. So let's save all. And now it's time to import the model. So for importing model, we need to create extra version without that plane as a placeholder because we don't need that. And after exporting the model from our DCC, we go to the material tab here and just uncheck import material. And we do the same for the textures. And let's import the model into engine. And after importing the model into the engine, I just bring the model here so we can see the model in the level. And now it's time to create the material, and let's create a new material and let's press OK. And after that, I'm going to create a material instance from that. That's perfect. Now it's time to open the static mesh editor and just place the material instance here into the material section. And remember, because in Unreal Engine 5.6, we are using Nanite as a default option when we import models. If there is any kind of visual missing information on your model, it's related to the Nanite setting. So you need to open the static mesh editor, come here to the Nanite setting, and just change the precision setting from auto to one of these items. You can place one of the setting here according to scale of your model and just press on apply changes. That's it. Okay, so let's go back to the material creation process. Let's go to the material, and for the first step, I'm going to select the material and I'm going to change the blend mode from opaque to the mask and shading model to subsurface. And let's turn on two-sided option here. Okay, now it's time to bring all the textures here. The first texture is base color. The second one is roughness, ambient occlusion, and the metallic. And the third one is normal. And this is for the mask that we are going to use in a second. So first of all, let's convert all this to the parameter. And right now, as you can see, all of these inputs are parameter and they have proper name, proper group, and a sort priority. So inside the material instance, we have this kind of arrangement. Okay, so we defined the base color, metallic, roughness, normal, and ambient occlusion. So what about the translucency and the opacity? For the opacity channel, I'm going to use the alpha from the base color. And because we have some blur inside that and we want to control it here, I'm going to load a power node, put the opacity to this, create a parameter, give a name to that, put the default value to 1, connect it to the power node, and put it in opacity mask. And we are done here for the opacity mask. But what about the opacity itself? We can call it as a translucency power, and I'm going to use again as an alpha channel for a main information here. Create a multiply, create another parameter, give a name to that and change the default value to 1 and connect it to the multiply. And after that, I'm connect the result of the multiply to the opacity. Okay, that's great. And for managing the parameters, I just create group for them and put them in the second priority. And for the subsurface color, I'm going to multiply this base color to the mask that we create for the translucency and put the result into the subsurface color. And for this purpose, we need to create a lerp and put the A, which is the translucency mask, to the alpha. And because in subsurface color, we define the translucency area should have color from the base color. And let's check the result of this lerp. So I'm going to change the static mesh here to the plane and just play this node. So as you can see, for the flower and for the leaves, we have color information and it's going to subsurface color output. And it means for the flower, And for the leaves, we have color information in the subsurface. But for other parts, we have just black. So it means there is no any kind of subsurface color and light absorption over there. Okay, that's it. So let's stop the preview, and it's a final output for the subsurface color. And remember, if we create a customization step on the color, we need to put the latest color changes to the layers here. Okay, so let's go and see what's happening if I save this material and apply it to the model, and we can check the result inside the viewport. Okay, let's go. So we have this beautiful result here. Okay, and let's open the material instance window, and as you can see, we have the inputs here and the parameters here. So in the opacity mask contrast, we can increase it to, for example, 50 to avoid any kind of leak opacity on the edges. And after that, we have translucent shift. So we can control the translucency effect with this slider, 1 and 0. Okay, that's great. And we are done in terms of setting up a material for this vase, but I'm going to create a customization step in this material. And we have two main phases. First of all, I want to create a color table for the flowers, and I want to change the color of the flowers when I change the position of the model. And the second part of the customization is creating a color tint on the leaves. So let's do that. First of all, before going to create a customization layer for the color, let's talk about the roughness, which is very important for us here. So I'm going to create a layers node here and put the G channel of the ORM to the alpha, which means I just use the roughness map as an alpha input in the layer. And I'm going to create a control gate for the minimum and maximum value on the roughness with the layer. So let's create two parameters. And after creating parameters and give them a proper name, I just put to the A, the mean part, and put to the B, the max part, with the default value of the 0 and 1. So it means we have roughness map as we export from Substance Painter. And whenever we want to remap the range, we can control that with the roughness minimum and maximum here. So let's put the result of the layer to the roughness input, and that's it. So we create a customization step on the roughness. Let's go and create a customization layer for the leaves of color. So first of all, I need a static switch parameter, which I'm going to ask a question. Do you need custom leaves color? If it's true, we should put the output of the customization layer. If it's not, which means it's false, we just need to load the base color information. Okay, so let's create some rooms for customization step here. And first of all, we have leaves mask under the G channel, and we want to create a color tint here. So this is my custom color parameter, and I'm going to put that in a 1. It means pure white. And let's multiply from base color with this color tint information. But the problem is, if I bring this RGB to the B and put this value into the A and just preview this node, if I change the color to something like red, because we have color information before, which was the green information, the preview here is not great, and we don't have red on the leaves. It's a combination between red and green. So for avoiding this kind of scenario, we need to desaturate the base color. So I'm going to use a desaturate node here, put the RGB to the first input, and bring a constant value with one value in the node and put it in the fraction. And let's just put the desaturation to the B. So as you can see, I have a great color tint on the base color information because the base color is not the base color that we import. It's a desaturation version of that. And it's ready to receive some color information from the shader. Okay, so perfect. But this multiplying here, it's universal effect. It means all over the texture, in all pixels, we have this color tint effect. So we need to limit this effect just only on the leaves area, which we have the mask of that and we created before. So let's create a lerp and put this G into the alpha. And let's put the result of the multiply to the B and the base color to the A. So if I preview this part, as you can see, we have this color tint effect just only on the leaves area. So this is the purpose of creating this kind of mask here. So let's put it into the true and connect it to the base color. And remember, because we are using subsurface color, we need to put the final result of the base color line to the subsurface section. So that's it. And let's check it in the viewport. Okay, now we are in the viewport, as you can see, and let's enable this custom leaf color. Okay, that's great. So we have reddish leaves here. And if I just come here and change the color to something like blue, as you can see, the translucency is changed too. And we have subsurface color based on what we have on the color tint. And we can control it like this. Perfect. And we have roughness, mean, and max. And it means we can control the roughness information on the surface very easy and very fast. Okay, that's it. And now it's time to create random color change for the flowers based on the position. For this part of tutorial, we need to create a color table, which is our source to pick up the color from this table to multiply that color to the flowers. And here, because we have flowers and we want to have different color, we go with a different color for each square and the grid cell. But for example, imagine that situation that you have a model that you want to just have a slightly different color tint. So you need to create a color table for that purpose on the family color that you want. So right now, this is okay for us. And as you can see, the size of this texture is not 2K, it's not 1K, it's just 128 pixel. And that's enough for us. Even lower size is okay because we just need to pick the color information from the pixel. So there is no any specific details that we need inside this texture. Let's save this color table and come back to Unreal Engine. So inside Unreal Engine, we just import this color table to the content browser, and that's enough. And now we need to go to the material and we need to bring it to our graph and convert it to the input. And that's it. And for this color table, we need to create a specific system for the UV. So first of all, I'm going to load texture coordinate. And after that, because the grid size of this color table is 3, I'm going to divide this texture coordinate to 3, okay? And let's convert it to the parameter and call it grid size. Okay, that's fine. And let's put this result to the color table. And as you can see, we have a square here. So if I add a note here that we can add some information to the result of the divide and put it here, for example, if I preview this texture here, and for example, put 0.2, you can see we have a change on the UV of this. And if I put a specific number here, I can change from this red cell to, for example, this yellow or bluish cell here. So let's create the logic for adding here to control over this UV. First of all, we need to load object position. And because we have 3 different coordinate number on the object position, we need to define which kind of position information that we need. For example, we can pick the X and Y axis or X and the Z axis. It's on us. But for here, I'm going to pick the X and Y axis for the U and the V multiplier. Okay, so let's go back to the material editor and I'm going to create a mask. And in this mask node, I'm going to mask just only red information. Let's duplicate it. And for the second one, I'm just going to unmask the G. The red is equal to X and the G is equal to Y. Okay, so we mask our information in 2 separate lines. And because we are working on word position or object position inside the word, we need to divide or define a grid of the information. So we need to divide this axis number to some specific number that we want to have. For example, we want to create a big grid size on 10 or 20 or 30 or 100. And it's like the snap system that we have here. If I go to the top section, this is our object. And if I draw a grid here, and if I divide the information from object position to 100, the result of this divide is these points. And these points are the information that I'm going to use to add to my UV coordinate. So it can be the scale of the changes on the UV coordinate. So let's go back to the material editor, bring some divide node, put a value here, and just give a proper name to that and just put 10 as a default value. Put the scale of changes to the B and put the mask result to the A of the divide. That's great. And now it's time to floor our result. And the floor is if we have, for example, 105 on the R or X axis and it's divided on the 10, it means the result here is 10.5. And when we floor this result, it's equal to 10. And it just round down the number that we have here. And with this 10, we can create an extra step and use that value in this add section. So let's put the floor here. And right now we need to multiply this result to a number. And this number should be the result of a divide of 1 on grid size. It means we are going to create a divide node here and put the grid size to the B. So right now we have 1 on the 3. So the result is something like this. Okay, so this is the step that we need to take from the first cell in the grid table to the next one. Okay, so we just create the logic here. So let me just put this to this section. Perfect. But the UV coordinate is a combination between U information and the V information. And here we have two lines separately and we need to append them together to have a float 2 type of information. So let's bring the append vector and put the Z to the A, which is equal to the U, and V to the B, which is equal to the Y. Okay, and now I'm going to put the append result to the add, and we have this logic here. And now it's time to test it. So for testing this, I'm just put this RGB to the base color. Let's save it. Let's go back to the viewport. And as you can see, when I change the position of the model, the color is changed here. So the logic is working here. So let's go back here and we need to create a limitation step like what we create here for the leaves color. So first of all, I'm going to create a multiply here, put the RGB to the A input, and I'm going to create a static parameter. And I just create an intensity controller for the flower color, and let's put the default value to the 1 and put it into the B. The second step is multiplying the desaturated map from the base color, like what we did for the color tint. And after that, we need to create a lerp, put the multiply result to the B, the base color or the result of the custom leaves color to the A, and just use the red mask in the alpha. And we need a question again. So random color on flower, and the default value is false. So if it's false, we need to load the result of the custom leaves. And if it's true, we need to use the result of these color changes here. And let's put it into the base color, and we need to define this one to the B. That's fine. So let's save it and test it on the model. So let's bring back the material instance window here. So let's enable this random color on flower and test it on the scene. So the color is changed. If I go to the unlit section, as you can see, the color is changing here, and we can have different pot with different color on the flowers without any extra step. And remember, you can control the grid size here. So if you just create a color table of 4 color in row and column, you need to change the grid size from 3 to 4. If it has just only 2, you need to change the grid size from 3 to 2. And you can just control the color intensity here, as you can see. And remember, you have scale of the changes. So if you increase this value, it's like you control how much change do you need on the move. If it's lower value, it means in lower step of the moves, you have the color change. If it's on the high value, it means you need to move more than before to have color change. So this is the logic behind that, and that's it. So I hope you like this video, you learned something new, and if it's so, please hit the like button, share your mind in the comment section, and if you need any kind of information or request for next tutorial, you just need to put it in the comment section. Don't forget to subscribe our channel, ring the bell, and if you need to access to the project file of this tutorial, you need to come to the Patreon page and you can support us over there. So this is the end. Be creative, be safe, bye.